Hello students, how can we find the domain of a composite functions? A composite function is made up of 2 or 3 functions. How can we find domain of a composite function which is made by 2 functions? Let's say we have 2 examples. Find this composite function of g of x, and in another side let's find g of f of x. Those 2 are different. Be careful, those 2 are different. Before starting this, we have to know what is the domain for this function and what's the domain for this function. Pay attention. The domain is for this function is from, let's say this is 0, this is negative infinity, and this is positive infinity, and this is 1, 2, minus 1, minus 2, like this. So that we can put any value in the place of x. So it is starting from negative infinity and it goes to positive infinity. We can say from negative infinity to positive infinity is the domain for this function. How about domain for this function, g of x? We can draw it on a number line. This is 0, 1, 2, 3, minus 1, minus 2, minus 3. Can we put 0 in the place of x? Yes, we can. Can we put 1? Yes. Minus 1? Yes. Minus 2? No. Because minus 2 plus 1, it becomes minus 1. And we have to say minus 1 we can put. And from minus 1 is the domain of this function. Now, I hope you understand this, guys. How can we find the domain? We can say x plus 1 is greater than or equal to 0, and 1 go to other side, x greater than or equal to minus 1. We can use this idea, okay? Now, let's find the composite functions first, and then we will decide what is the domain of this composite function. Pay attention, we can give the x to only g, not f. We have to give to the function g before f. So we will say f of g of x. G of x. Okay. Find what's g of x? G of x is square root of x plus 1. Right? Instead of this, equal to square root of x plus 1. And then f of x is equal to what? F of x is equal to x squared minus 1. But this is not f of x. This is f of a bracket. So clean this x and write this bracket. Square root of x plus 1. And then what should we do? We can cancel square root with square, okay, and the answer it becomes x plus 1 then minus 1. Guys, be careful, this one it will not be absolute value of x, because we in this part we have only positive, so we can say x is always positive numbers. So plus 1 and minus 1 is only x, okay? Plus 1 and minus 1 cancel, those 2 cancel, only x's remain. What is the domain of this x? The domain for the x, not for the g. This is equal to g of f of g of x. Okay? The domain for this function, without saying this is a composite function, is all real numbers, isn't it? We can say this is 0. Let's see. Let me draw it in another way. Sorry. This is 0, this is 1, 2, and this, let's say, positive infinity, and this is negative infinity, minus 1, minus 2, like this. So the domain for this function is, if we say this is only x, so it is all real numbers, okay? From negative infinity to positive infinity. But be careful, will not be the domain for the composite function, because this is made of two functions, and the most important one is this g. Find the domain of this g is from -1 to positive infinity. So we can say, where's -1 here? Draw it in this number line. And what is the intersection between this blue and this black one? The intersection is from here to here, or let me say in another word, what is the parts that we have, the red, the blue and the black one, we have from -1 to positive infinity. From here, guys, to there, we have both blue and black. But in this side, we don't have blue, okay? So the intersection between blue and black one is from -1 to positive infinity. So the domain is from -1 to positive infinity. Guys, this is the easiest way that you can do it, and you will be sure how to find the domain of a composite function. The most clever students will understand these, okay? Only cleverest students can answer these kinds of examples, okay? But the others, maybe they can't. But if you use this idea, all students can answer the questions. Now let's go to the second one. G of f of x, g of f of x is equal to, we have to give this x to f, it becomes g of f of x like this, and f of x is equal to, my markers, okay. F of x is equal to what? X squared minus 1, and let me write here g, okay, and then we have to put, what's g of x? G of x is equal to square root of x plus 1, but instead of this x we have to put the bracket, okay, I'll put the x squared minus 1, and then this minus 1 and this plus 1 cancel, x squares remain. Now this can be positive and negative. When we cancel those two, it becomes an absolute value of x, okay? It becomes an absolute value of x. So what's the domain for this? Is all real number. Let's draw it here. This is 0, this is negative infinity, and this is positive infinity. Okay, the domain for absolute value of x, you can put any number, so all real numbers. This is g of f of x. And the domain for the second one is, let's say this is second one, f, we have to say f of x is domain is all real number. So again, all real numbers. What is the intersection between the black and the blue one? Is all real numbers from negative infinity to positive infinity. So domain, we can say domain is from negative infinity to positive infinity. Be careful when you find the equation, you have to compare with the second function and what's the intersection between them, in which part they are repeated, so it will be the domain of the composite function. I hope you guys understand this very well. Bring two examples and find the composite function, and then find the domain of the composite function. Thanks for watching the video. Bye.